Welcome to Module 7 on simplifying expressions. Right now, pause the video, get out your writing utensil and your piece of paper. Don't forget that a spiral-bound notebook is perfect for what you'll need for this course. If you don't have one, you need to get one now. Let your teacher know, email her, email him, tell them you need some help getting a notebook, and we'll make it happen. Note-taking is important so that you have access to what you're learning without having to rewatch every video. Plus, you can use your notes on the quizzes. At the top of a new page of notebook paper, I want you to write Module 7, Simplify Expressions. You don't need to write all of these down. We'll write them down as we go. Today we're going to be talking about combining like terms. We're going to use the distributive property. We're going to talk about how to multiply a constant with a monomial, which is something that has a variable. We're going to identify the parts in an algebraic expression, and we're actually not going to do identifying properties. We took that out. All right, unfortunately you have some vocab to write today, so you might want to pause the video, write this stuff down. You don't need to write everything, so if you want to wait for me to underline what you need to write, that would be great. You need to start a new topic, so parts of an algebraic expression, and underline that. And then our first vocab word is term. The terms are the parts of the expression that are added or subtracted, so you need to write what I've underlined in blue there. You don't necessarily need to write this one down. Sum is the result of adding. If you don't know that, you can write it down, but most of you know that sum is add. A variable is a letter or symbol that stands for some number. And if you want to, you can just write letter, a letter that stands for some number. A constant has no variables. It's a single number. So like 5 is a constant, -7 is a constant. Like terms. Two terms are like terms if their variable parts are exactly the same. So like 3x squared and 4x squared are like terms, but 3x and 4x would not be, okay? Because, I'm sorry, I should write that again. 3x and 4x squared would not be because their variable parts have different exponents. So the variable parts have to be exactly the same. Coefficient. I use the stem co to help me remember. Co means together. Coefficient is the number written as the multiplier. So for example, in 4x, 4 is the coefficient. You don't necessarily need to write this down, but write it down if you don't know it. Product, a product is the result of multiplying. And last one, factor. A factor is a number or expression that is being multiplied. A number or expression that is being multiplied. Pause the video, get all of this stuff written down because you're going to need to refer to it here in just a second. So let's see if we can identify some of these parts. So what we've got here is an expression. We've got 4 being multiplied with 3 plus 8 being multiplied with 5b plus 9. It first wants us to look at the 5b plus 9 and decide whether 5b is a constant. Well, remember, a constant has no variables. It's a single number. So we would not select this as one to be true. 3 and 8 are like terms. Well, remember, like terms have to have their variable parts exactly the same. Well, this one looks a little weird, but we would mark this as one of our answers. 3 and 8 are like terms because neither of them have a variable. In 5b, so we're only looking at 5b, 5 is a coefficient. Well, remember, coefficient is a number written as a multiplier in a variable expression. Is 5 being multiplied by b? It is, so we would mark that as true. This says 5b plus 9 is written as a sum. It is of 3 terms. Well, this is only 2 terms. 5b is being added to 9. Remember, terms are things that are being added or subtracted, not multiplied. So we would not mark this as one that is true. 4 is a factor. Well, remember, a factor is a number or expression that is being multiplied. 4 is being multiplied by 3 plus 8, so we would mark that as one of our options. And we did find some of those as true, so we would not mark that one. Would you pause the video and try this one on your own now? So for the first one, in 2u, 2 is a coefficient. It is. 2 is the multiplier part of the variable term. In 2u plus 9, 2u is a constant. It is not. 9 would be the constant. The constant is the number that doesn't have a variable. 7 is a factor. It is because it's being multiplied by something else. 1 and 3 are like terms. They're both constants. Neither of them have a variable. 2u plus 9 is written as a sum of 3 terms. Well, it is a sum, but it's only a sum of 2 terms. And I would not mark that none of these are true because we already said that 3 of them are true. All right, new topic, combining like terms. Addition and subtraction can only be performed to like terms. So you need to write this down. Addition and subtraction you can abbreviate with plus and minus. Addition and subtraction can only be performed to like terms. Don't forget that like terms have matching variables and matching exponents. You might want to write yourself a note for that if you think that you'll need it. We also want to remember that anytime we see a variable that doesn't have a number, that means there's just one of them. So there's an invisible one there. I have to have like terms to be able to subtract, and I do because these both have C's. So this becomes 5C take away 1C, which is 4C. You try this one on your own. For this one, you should remember that there's a 1 with the B, so we do 6B take away 1B, which is 5B, and we're done there. These can get a little bit more complicated when we start throwing in more than one variable. You don't need a new heading for this. We're still combining like terms, but we only have 2 that have like terms. 3D and 5D can be combined to make 8D. There is no equal sign, and so I cannot go any farther with solving because there are no more like terms. 3C and 8D can't be added together. That would be like adding 3 cats and 8 dogs and saying I had 11 cat dogs. It doesn't make any sense. You pause the video and try this one on your own. You should have recognized that 2B and 7B were like terms, so we add those together and we get 9B there. We can't add those together any farther because they're not like terms and there is no equal sign, so I can't solve. Now, new topic, multiplying with variables. Addition and subtraction can only be performed to like terms, but we can multiply anything we want. You can multiply cats, you can multiply dogs. I can have twice as many cats as I have dogs. You can multiply anything you want. So 4y times 3, I don't need the 3 to have a y, that just becomes 12y. Don't forget that the parentheses with something next to them are telling you to multiply, so 6y times 3 becomes 18y. You pause the video and try this one on your own. You should have recognized that the parenthesis is telling you to multiply, so 4 times 4 becomes 16v. Now, we learned that so that we can move on to the distributive property. The order of operations says we need to get rid of parentheses first. By the way, you should have made a new topic here, understanding the distributive property, and then underlining that in a new section of your notebook. Sometimes we can't evaluate what's inside of the parentheses. The distributive property can help, so let's make sure that we understand the distributive property first. If you were to solve this using order of operations, you would do parentheses first, and then you would need to do 6 times 14, which I can't do in my head, so I would do 6 times 14 in my calculator, and I would get 84 for that. But there's another way to do this. We can use the distributive property to rewrite this. I can do 6 times 4, but I can also do 6 times 10. This is a little easier to do in my head because 6 times 4 is 24, 6 times 10 is 60, and that becomes 84. It's definitely not necessary to solve a problem like this using distributive property. In fact, I would argue that it makes this more complicated. If I can just go ahead and add 4 and 10 and multiply by 6, why wouldn't I? But what if there's a variable inside the parentheses? For example, let's take a look at this first one. I cannot subtract 7 and u. They are not like terms. If that was 7u minus 1u, I could make that 6u, but it's not. There's no way for me to simplify that, but the order of operations says I need to get rid of my parentheses. Instead, I can use my distributive property. I multiply 11 times both of these things. 11 times 7 is 77. 11 times u is 11u. I can't subtract those because they're not like terms, and there is no equal sign, so I'm done there. You pause the video and try this one on your own. You should have recognized that you can't add y and 7. Instead, you need to distribute 12 times y, which becomes 12y, and 12 times 7, which is 84. Oops, what did I forget? Can you find my error? I forgot my y. 12 times y is 12y plus 84. There is no equal sign here, and these aren't like terms, so I can't go any farther. One of the things I didn't mention when I did the first one is that signs are important. If I do 11 times negative u, there should be a minus in the middle to indicate that it's negative there. If I do a positive times a positive, there should be a plus there. If I write this as 12y84, it's wrong. I either need to be adding or subtracting in the middle there. I can do this with larger types. I can distribute everything that's in the parentheses. There's three terms in here, negative 2y to the third minus 3 plus 4w squared. None of those are alike, so I can't combine them. The only thing I can do is distribute that negative 7. Negative 7 times negative 2 is positive 14, and I just bring down the variable. Negative 7 times negative 3 is positive 21, so I bring that down as plus 21. And negative 7 times 4 is negative 28w squared, which would be easier to do more work with since I don't have the parentheses. For one like this, when it's backwards, you are more than welcome to move that negative 7 to the front if that bothers you. This is the exact same problem as the one above. You pause the video and try this one on your own now. You should have distributed your negative 7. Negative 7 times 3 is negative 21. Negative 7 times negative 2 is positive 14v. And negative 7 times 4 is negative 28w. None of these are like terms, and there is no equal sign, so we're done there. Now, we can also simplify what we call quadratic expressions. So new topic, simplify quadratic expressions. When you see a quadratic expression, all that simply means is that we have some x squared terms and we have some x terms, and they're not alike. These are two different types. So this says to simplify the quadratic expression. So what I've got here is negative 10x squared minus 9x squared. Those add up to be negative 19x squared. And then I've got negative 4x and positive 7x, and those are alike, and those add to be positive 3x. And then the plus 3 just comes down. I'm not squaring the 19. Whatever is in here would be squared, but I don't know what x is, so I'm done there. You pause the video, use this one as your example, and try this one on your own. You should have recognized that you had a set of like terms that had x squared. Negative 8 minus 3 is negative 11x squared. Negative 2x plus 7x is 5x. And then we just bring down the plus 5. You can also rewrite this and line up your like terms. So as I go, when I run into something that I already had, which is an x squared, I can line that up. And I can put things that aren't alike at the end. In this way, I would have negative 11x squared plus 5x plus 5. Either way is the same. Most people end up preferring this way, but this way is just fine as well. All right, you're done with Module 7. Now you need to go to ALEKS. You need to log on and complete each skill in Module 7. Don't forget that you can click on the explanation to get extra help if you're struggling, or click on the why if you'd like to understand more. And then you never want to forget to take the quiz that goes with each module. You're going to go back to the home screen, click on the circle with 3 lines, click on assignments, and find quiz 7 to match with Module 7. Great job. Have a good day.